Okay, so let's get started here. Good morning, good afternoon, good evening to everyone attending. Thanks for joining. Before we get started, let's just go through some quick logistics. So everyone will be muted during the whole session for better recording quality. Please use the QA button to submit any questions that you might have. We will try to answer them live as we speak, or we will also leave some time at the end for us to go through any questions that might have not been answered. We will be recording this session, so yes, it will be available. The recording will be available as soon as it will be done on the Tableau community forums in the server admin forum area, where we will also share the slides and any other material that we will go through today. So welcome to the Tableau Admin API Toolbox session. So when I started at Tableau about 9 years ago, we barely had any APIs. And throughout these years, the number of these APIs has grown exponentially. The number of use cases, interfaces, and options has become overwhelming. And we hope to bring some clarity to you admins today. My name is Emiliano Colosimo, and I'm a technical architect director in the professional services team at Tableau. I've been at Tableau for close to 9 years. I started as the first solution architect in EMEA, particularly in the London office, and I relocated to the Bay Area in 2017. In these years, I've been helping clients adopt, implement, and scale Tableau throughout their organizations. With me is Andrew.
Thanks, Emiliano. Hi, I'm Andrew. I've been at Tableau for 1 year now, working with some of our largest clients to automate the governing of their Tableau server and develop self-service tools for their users so that we can scale Tableau to reach organizations. I'm based out of Kansas City and have plans to relocate to the Bay Area in September.
Great. So the goal of this session is to help you understand the Tableau API landscape, but from a Tableau Server Admin's perspective. We will learn about which APIs are available. We will explain which APIs to use and when by showing some use cases that you guys can then go and apply. And ultimately, we hope to inspire you to learn more about how to use them and then come up with your own solutions. Now, please keep in mind that this is an intro, so we will not be going too deep on each of these APIs, but we'll be spending about 45 minutes today with some Q&A at the end. So I will be moderating, so any questions that you may have, please post them in the Q&A, and I will answer them as much as we can. But for now, let me hand over to our API rockstar, Andrew.
Thanks, Emiliano. So let's get started. And let's start talking about the Tableau Developer Platform. The Tableau Developer Platform is the part of Tableau that hosts our API suite. And there's many APIs available on this platform. But today we're going to talk about 4 of the common ones we see admin teams using. The first is the Tableau Server REST API. The Tableau Server REST API allows us to programmatically interact with the Tableau server. So think about creating sites, updating users, creating projects, publishing workbooks, publishing data sources. Pretty much anything you can do on the server UI, you can use with the Tableau Server REST API. Next one is our Hyper API. Our Hyper API allows us to create and update Tableau Hyper files. As many of you know, Hyper is our Tableau proprietary database technology that all of our extracts are built on. So what really it comes down to, the Hyper API allows you to build and update extracts. Third, we have our JavaScript API. Our JavaScript API allows us to embed Tableau vizzes, dashboards, and views in different web applications and portals, and interact with those dashboards and views as if you were using them on the Tableau server. And finally, there's the Metadata API. The Metadata API allows us to query assets and metadata that has been indexed by the Tableau catalog. So now that we kind of did a brief overview, let's dive deep into each of them. So first, again, is the Tableau Server REST API. And like I said, this gives us programmatic access to work with your content, users, projects, sites, and more on the Tableau server. And there's many different examples of how we can do it. The first is we can trigger extract refreshes. So we're starting to see some use cases where admin teams users are building these complex workflows where they rely on multiple flows, multiple extracts, multiple refreshes to run, and they need to trigger them in a specific order to get their ETL process to get their clean data. What we're seeing them doing, instead of using Tableau schedules, they're actually using the REST API to trigger all their extract refreshes flow jobs in their sequential order and then check status on them. We can kill background jobs. We actually have an example on this later. Pretty much what this does allows us to kill jobs in bulk. Say there's an issue happening on your server. Jobs are stuck in pending. We can go through, we can kill all pending jobs on the Tableau server with the REST API. We can create tags. So we can tag different important workbook data sources. We can update connection details. So as we know, password management's a big thing. People having to update their passwords every 30, 60, 90 days. And when they update their password, they also need to update their database password on the Tableau server. And with the REST API, we can actually build a solution where we update a user's passwords for all of his different connections on the Tableau server using Python REST API. And finally, we can assign permissions. So we can grant users permissions to different workbooks, groups, projects, and we'll have another example diving deep in that. So now that we kind of talked a little bit about the Tableau Server REST API, let's explain how do I use it. So it's a RESTful protocol. What this means is we send HTTP requests to the endpoint on the server with specific information in that URL and body. Each request pretty much equals one action on the server. And it can be done in any scripting language, Python, Go, Java, curl, pretty much anything. But what we really see common is that we, instead of using a single curl command, we use something like Python, where we can string together multiple requests and create a real solution. And what's really nice about the REST API is the permission model follows what's on the server. So each user logs into the REST API as themselves. And if the user has access to do it on the UI, they will have access to do it over the REST API. So server admins can interact with anything. Project leaders can interact with just the stuff in their project. And if you're just a workbook owner, no elevated permissions, you'd only be able to use the REST API on the workbooks and projects you have access to. So that's the REST API in a nutshell. The Hyper API. We can create custom scripts that interact with extract hyperfiles. And there's some really good examples, use cases for this too. We can store audit data. So at the end of this presentation, we're going to show you some examples of API solutions we built. And we'll actually use the Hyper API to store all that audit data to keep track of whatever applications are doing so that admin teams can audit it and monitor the output of our scripts. We can update existing extracts. So let's say you have an incremental extract on the Tableau server and it's getting really big. But you don't want to do a full refresh because then you're going to lose the entire data. What we can do is we can actually download that extract and clean it up with the Hyper API, get that size under control, and then republish. So we can keep the core data we need without losing the full incremental refresh. What's really nice about this is a self-contained database. So pretty much what this means is through our script, we can spin up a Hyper API, a Hyper process, create a database, query it, add data, insert data, delete data, publish it to the Tableau server. Then next time we need it, we can just re-download it and keep interacting with it, keep republishing, keep appending data to it. So it gives us a self-contained database within Tableau. And finally, like I said, we can create extracts. We'll have an example later on how we're using the Hyper API to create COVID vaccination published data sources for all users on our server to use using the Hyper API. Okay, let's talk about the JavaScript API. JavaScript API allows us to embed and programmatically interact with individual published dashboards or views. There's some really cool things we do. We can build fully custom portals with analytics as its backbone, but the analytics is actually from Tableau. So instead of having to use D3 or these different analytics extensions in JavaScript, we can actually embed directly our Tableau visualizations dashboards into our portals. We can embed analytics in websites, So a really good example right now is COVID, huge thing going on in our world. And you're seeing a lot of these different counties, schools, universities, they're all tracking COVID data. And a really good example is in Notre Dame University, where their COVID tracking dashboards are actually published to a Tableau server, and they've just embedded it onto their Notre Dame website. So that's how they're using embedded analytics in the JavaScript API. Embed directly in user workflows. As we all know, Salesforce has bought Tableau, and there's going to be a lot of integrations built between the two. But right now, what we're seeing users is that a lot of salespeople, they want to stay in Salesforce. They don't want to have to be jumping between applications to see their analytics. So with the JavaScript API, Salesforce Lightning, we can actually embed dashboards directly into Salesforce. So the sales teams can stay in Salesforce and get their full analytics, their full dashboards, get all the data at their fingertips within Salesforce. And finally, for admin teams, we've seen a couple different use cases where an organization, you could have multiple Tableau server deployments. And each of these Tableau server deployments, they have their own custom admin views tracking it, make sure their server's running healthy. And then they need to go between each of their servers to go check all their deployments at once. But with the JavaScript API, we could actually embed all of those custom admin views into a single spot. So the server admin team just has a one-stop shop to pretty much view all of their different health of their server deployments in one portal. And finally, there's the metadata API. Oh, sorry, I forgot to mention how to use the JavaScript API. So really how the JavaScript API works is it runs JavaScript on a browser. So the code needs to be deployed to a web server so users can access via a browser is how the JavaScript API works. A metadata API, it enables users to discover and query assets and metadata indexed by our Tableau catalog. And you're not familiar with the Tableau catalog, it's pulling in all the different information. So creating that data lineage of where our database, what databases, tables, columns, our workbooks and dashboards are using on the Tableau server. And there's some great use cases. We can do custom SQL tracking. So with the metadata API, we can pull any workbook on our server, on our site that's using custom SQL. And maybe we notice that some of these custom SQL workbooks, they have performance issues. We can actually get the underlying queries that the custom SQL is built with, and we can go and work with our end users to help maybe fine tune those queries, get those dashboards performing better. As I mentioned, we can query the data lineage. We can see where our workbooks, where the data in our workbooks and data sources are coming from. And we can get from the database it came through, the flows it ran in, to the final end result of our dashboards, data sources, workbooks, all through the metadata API. What's really cool about this, it allows us to start doing some really cool things around data privacy. So now that we know what's in our Tableau server, the source columns of the data that's making up our workbooks, dashboards, and data sources, we can actually start checking those columns against maybe our clients list to see, hey, maybe we're tracking PII, but let's see if any of those PII columns are being used in Tableau. So with the metadata API, we can create that connection between the two to actually find where PI is being used and manage the PI on our Tableau server. Tableau Professional Services actually has a solution around this called PI Data Manager, and I would encourage you, if you're interested, to reach out to your account executive. And finally, we can do impact analysis. So if I delete a flow on the Tableau server, say I don't think it's being used, what are going to be the downstream effects? Which workbooks, data sources, subscriptions are all going to be affected by deleting an object on the Tableau server? We can perform that impact analysis. So the metadata API is actually a little different to use than the rest of the Tableau API suite. It's built on GraphQL. And there's two ways we can query this GraphQL. The first way is we can actually go directly to our Tableau server. So if we're in the server, we can go to the External Assets tab, and we can go to this GraphQL interface. And here, this lets us run queries directly, and we can return the result. For this, so this is how it works in the Tableau server. There's also another way. The metadata API has a REST endpoint. So what we can do is we can send JSON queries to this REST endpoint, and then it will return those queries in a JSON format. And then any scripting or coding language can send and interact with that REST endpoint. So and again, the metadata API follows the permission model you see on the Tableau server. So users can only get results of their GraphQL queries for workbooks, data sources, flows they have access to. So server admins will be able to query the entire server. Project leaders would be able to query stuff that's in their project workbook, or data source owners would only be able to query what they own. So that's a really quick introduction to the 4 APIs that we're going to talk about today. Now that we kind of learned a little bit about them, let's see some real world examples of how server admins can use them. So our first 4 examples will be really simple use cases, and we'll actually be sharing the code with you. So we have a spot on Tableau Ignite where you can actually go download the code we're talking about, use it, start learning from it, try to implement it. And then the last 3 examples are going to be power use cases. These solutions were built by Tableau Professional Services. And since we are engaging with customers on these solutions, we're not going to be able to share the code, but we think it's important to show because it showcases the full capability and power of the Tableau Developer Program and the APIs that Tableau has available. Okay. So the first example we're going to discuss is, let's talk about how we can automate user onboarding. So user management is a big task for admin teams. As we know, only server and site admins can onboard users and groups to a Tableau server. And the REST API actually allows us to create users, create groups, add in a group. So this allows us a lot of ways to automate the user provisioning process. And the example we're going to look at, we're actually going to look at once the users and groups are on the Tableau server, let's assign them permissions to some default workbooks, maybe a couple projects, something to get them started on the Tableau server so that they could see examples, interact with data, and create their first workbook or dashboards. So what I plan to do here is kind of walk you through the highlights of the code. And then we won't go too far in depth, but this will be shared with you guys as well. So this code is written in Python, and it uses something called a Tableau Server client. And what that is it's the Python library wrapped around the Tableau Server REST API. So there's many different Python libraries available to use to work with the Tableau Server REST API, but the Tableau Server client is the only one built and managed by actually our dev team at Tableau. So I really recommend it for any work with the REST API. So it's really simple here. We store our variables for the script to run. It's really static right now, but in a real workflow, we would be dynamically passing in the name of the project users and groups. But just to show you how it works, and so you can test the script yourself, we'll make this a static function. And how Tableau Server Client works is, first, we have to authenticate. So we create our authentication object, we create our server instance, and then we sign in. So now we're under this with block. So anything under this block will be signed into our Tableau server, now interacting directly on the server over the REST API. So first thing we want to do in the script is we're going to find a workbook and grant either a user or group the explore options, the explore permission role to that workbook. So we'll search for the workbook. As we know, workbooks on the server can have the same name, but if it's in a project, only one workbook per project can have the same name. So we'll ensure that the workbooks we find on the server are in the project we expect them to be in. And once we find that workbook, we'll start granting the permissions capabilities to it. So here is the different capabilities we'll be adding. We're going to give them read, filter, view comments, add comment, export image, export data, share view, view underlying data, web authoring, and we're going to give them the allow permission. If we wanted to, we could give them deny for maybe web authoring, but right now we're just matching what the explore option on Tableau server gets you. So once we have the capability set on what we want to grant, we then check, are we granting a user or a group? If it's a user, we need to find that user on the Tableau server. And then we find the user and we update permissions. We give them those roles. Same action with the group. We find the group, set their capabilities, grant them, run the code to grant them those roles. And now when they log in for the first time, they'll be onboarded and they'll have starter projects, starting workbooks, starting data sources to get them started on their Tableau server journey. So that's kind of how we'll go about automate user onboarding. Emiliano, is there any questions in the chat about that?
No, not specifically for this one, I don't think.
Okay,
but if there are,
cool.
please post it in the Q&A and we'll answer as much as we can towards the end.
Yep, so we'll get moving on to our next example then. So the next example is around our COVID-19 vaccination data. So we've had, Emiliano and myself have had a couple clients where their teams need access to reliable, up-to-date COVID-19 vaccination data for various business purposes. As you can imagine, tracking vaccination data is important for organizations, seeing when they can reopen, projection model, growth model, future profit. All that, this vaccination data is really key to businesses today. And there's a couple of different ways we can go about getting this data. We sell in a way where we actually use the Tableau Hyper API and REST API to create a published data source that's updated daily with the up-to-date COVID vaccination data. And you might be asking, why are you using scripting instead of a web data connector? And there's really one major reason for it. To update, to get a web data connector set up on the server, you have to whitelist it. So you have to run commands, and then actually you need a TSM restart. So you need downtime to whitelist the web data connector. But with this script, with the Tableau Hyper API, we can actually pull the data directly from GitHub and about 2 lines of code, and then create our extract and publish it. So there's no downtime needed. We're not really whitelisting any IP addresses to our server. So it's a really secure way to bring in external data. And what's cool about this process is the process I'm about to show you can be used for almost any external data to bring it into your Tableau server in a secure and automated fashion. So maybe you need stock market data from outside source. You could need just like COVID cases data, health and safety reports, regulation, anything really external data where your users could see a need for using it. We can use Tableau Hyper API, REST API to create an extract and publish it to the server. So let's take a look at this code and let's walk through it. Okay, so we're using a couple different libraries, and this one, the first script we showed, we only use Tableau Server Client. And this one we're using Pandas. If you're not familiar, Pandas is a really good data science library. It's used a lot in machine learning, working with data, visualizing data. So we'll use that here. Again, we're using our Tableau Server Client to publish the data sources. We're using the request library to get the data from GitHub. And then we're using this IO, which is we're converting bytes, pretty much, bytes to readable format. And finally, our Tableau Hyper API. So the really reliable data we found for this on the COVID-19 vaccination data is actually kept as CSV files on GitHub. So this team, OWID, as they're running these ETL processes every day, and then they're publishing updated CSV files to GitHub, where then people can go download the CSV files and interact with them as they need. So how this works is we first download our data. So we run this Python command to get one of these GitHub links and return the CSV file. We then turn that downloaded data into a Pandas data frame. So now we have all the data we need from GitHub to go and create our published data source. Let's look at how the Hyper process works. So what this is doing is actually creating a local Hyper process on your server. On your machine running the code. So we start our Hyper process, we connect to it with our Hyper file. We create our schema, and now we create our table definition. So this is really important. When you're creating an extract, you always need to follow these steps first. Start your process, make your connection, create your schema, create your table. And let's look about how we create our table. So we give the column name, the SQL type, and then if it's able to be a nullable object. We keep doing this for all the different columns that are in the CSV file. And what you'll see is this column structure directly matches the GitHub structure of that data. So once we create our table, it's really simple. We just loop through our pandas data frame, we iterate the rows, and we add each row to our extract, and finally we execute. You can think of the execute function as your SQL commit function. So this is bringing in all of our data from that downloaded CSV file to an extract. We repeat it for the 4 different COVID-19 vaccination data related CSV files. And finally, once we're done, we again use the Tableau Server REST API to publish up the data. So, and then last one we're going to talk about is this solution where I was actually on site at client site. And we noticed an issue where their background or jobs were stuck in queue for a really long time. We're talking about like a subscription job in queue state for 2, 3, 4 hours, extracts in queue state for 2, 3, 4 hours, and we weren't sure why. Further investigation let us find that many jobs were stuck in pending state for some reason. So our first reaction was like, okay, let's go to the Tableau server, let's kill these pending jobs. But on the Tableau server UI, there's no way to kill jobs, background jobs in bulk. You have to manually go to the jobs and click on each one and click kill. We had thousands of jobs stuck in this pending state. That's not feasible to do. I did some little research and I realized, hey, with the REST API, we can actually query every pending job and kill it automatically. So I quickly developed a Python script to kill all the pending jobs. Once the jobs were killed, the backgrounders were gracefully recycled using TSM hop topology changes. So let us recycle the backgrounders without requiring a restart. And then finally, post-cycle, recycle and pending jobs killed, all of our background jobs returned to normal. The script I'm about to show you is unique. I didn't use Tableau Server Client. I'm actually directly calling the API over Python request library. While directly calling the API is more complicated to build and develop, it gives us a lot more flexibility when writing scripts. So what I really recommend is when you're first getting started using the Tableau Server Client, once you become more mature in scripting automation, you can move to directly calling the REST API. So I thought this would be a good example to share as well. So here's the script that loops through, grabs all the pending jobs and kills them. But what I really want to show you is how we call the REST API directly. So again, we use Python request. This allows us to send HTTP request. And this is an example of querying the jobs that are in the pending state. We have our URL and we have our pagination. So with the REST API, we can only return so many items at once. So we're going to return jobs in pending state 100 at a time. We're going to keep looping through this call until we return all the pending jobs. So we run our request get to the URL. We pass in our headers, verify. We check the status code. If it's an error, we log our error, let us know there's an error with the request. If it's a success, we get the result, and then we start looping through the result, seeing, hey, are there more jobs left that we still need to query? That's what this part's doing. And then for the jobs we pulled, let's ensure they're actually pending and append them to a list. Pretty much right here, it checks, did we return everything? Once we run this function, we now have every pending job, and we just loop through that list of pending jobs and we kill it. So this function right here, we pass in all of our needed variables, we send the request to kill that job. And all of this is maintained in our parent function. So that's how you go about calling the REST API directly. And again, all that code is available. So there's this TableauFans embedding page. I'm no expert with the job. Well, I know enough to be dangerous with the JavaScript API. I'm still pretty relatively new to front-end web development. Most of my career has been back-end, but Tableau, we have this employee named Timo, who is pretty much Zen master level with JavaScript API embedding. And here's his blog. We're kind of short on time right now, so I won't go into the blog, but feel free. This is hyperlinked on the PowerPoint, so just click the blog. It'll take you to a page. It'll take you to here, and you can actually open up all these different embedding examples, and you can download the code here. This gives you the code on how he embedded his Tableau business, how he interacts with them, if you're curious on how to use the JavaScript API. Okay, so that was it for our examples. We'll be sharing the code. Now let's talk about some of our power use cases. So the first power use case we're going to talk about, or solution developed by Tableau Professional Services, is how can we have users create projects? Right now, only admins can create projects, and that can lead to enterprise organization level. Admins can be getting a lot of tickets around, hey, I need a top level project created. Can you assign permissions to this project? All this stuff that we really want admins to spend their time on looking at issues, troubleshooting other tickets. Creating projects is a pretty routine task. So what if we could free up admin time, alleviating them the responsibility of creating projects, and allow our users to directly create top level projects on the server? And that's exactly our business case with this solution. How can we create a self-service tool to allow users to create projects? And what we came up with was self-service project creation tool. It's a three-part application. So the first part has to be self-service. It needs to be full self-service, used by the users, and it needs to be reliable. We don't want our admins troubleshooting this tool, or it'll be more time efficient for them to just create the projects themselves. The tool needs to be secure. Only users with access to the dashboard will be allowed to create projects. And then also, this service is built on top of Flask. If you're not familiar with Flask, it's a Python microservice web framework. And this Flask REST service is going to be sitting on our corporate network. So we need to secure that service so that only users accessing the dashboard are able to create projects. And finally, the tool needs a simple UI. Users should be able to look at their dashboards and know immediately what needs to be done. So let's walk through a simple workflow on how this application works. I am a Tableau server user looking for a project. I go to our project creation dashboard and I fill in my parameters for the project name. I then send the creation request to our Flask server. Within that creation request is a request token, and Flask checks the request token status. If the token is invalid and user is redirected to error message. Hey, something's wrong with your request, you don't have a correct token, we can't create this project. Or the token is valid and the request can continue. So the project is created and user is redirected back to Explore page with their new Tableau server project created. So let's do a quick demo on this. So I'm a user looking for a project. I come to our project creation dashboard. What I do is I give a project name. Sorry, let's reload. I give a project name and it checks to make sure that project name is available. We also do some checks in there to make sure no special characters are used, anything that could break our Flask service. Example, add the $, we get an error. But once I have a name suitable to use, I go ahead, click the button, and we now see our new project, virtual user group. So Tableau Server REST API does have one limitation. We can't change project owner. So the owner will be the name of the user we're running in the Flask to send these requests. But what we do is we send the requester, the person who requested the project, we make them a project leader. So as a project leader, they have all the same rules, responsibilities, roles as a project owner. So even though they're not technically listed as the owner, they're a project leader. They can set permissions, add users, do all those roles as a project owner. So that's one example how we're using the Tableau developer program to create a solution around self-service project creation. So the last power demo I want to show is Design Auditor. And what Design Auditor does is we find slow performing views on the Tableau server, and we actually go about and audit them to find out what's making them slow. Then we let the end user know, hey, we ran this audit, this is what we found, here's how you can improve your dashboard performance. And this came about because we noticed 3 challenges around dashboard performance. Bad workbooks can first give the impression that the server is slow, but in reality, we know the server's not slow as admin teams. We know it's most likely a poor performing dashboard, badly designed dashboard that's giving the users the impression that our server is slow. Quality. As an admin team, we don't have the ability to control the quality of content published. Tableau is a self-service analytics tool. Anyone is able to publish workbooks, dashboards, data sources once they have the required license. And finally, we notice that our users, while they're taking e-learning, doing all those training, sometimes they have trouble taking what they learn in e-learning and applying it to their dashboard creation. So these 3 challenges led us to this business case. At an enterprise scale, how can we promote performance best practices in design? And what we came up with is Design Auditor. A Design Auditor is a 4-part solution. So the first part is we grade poor performing views by using a combination of the Metadata API and actually parsing the workbook XML directly. This allows us to see exactly how the workbook was built, and we compare that to best practices. Once we get all that data, all that comparison, we send the results of the checked views to an email, and an email to the user's easy to read body. So the email was based off a credit score design. So we give them their overall score and their 12 criteria that made up that score. The email needs to be educational and include links to internal wikis on how do you go about performing these best practices? How can we empower our users to teach them how to use these best practices in design? That's done through these internal wiki links that are embedded throughout the email. And finally, we use the Tableau Hyper API to store all these results in a row level security data source with starter dashboards for results analysis. So again, we'll walk through the workflow. I'm a Tableau administrator. And what I do is I go to all this application is ran through actually a configuration dashboard. So I can update the parameters on the dashboard to get Design Auditor to run exactly as I need it to at my organization. We then use Python to pull a list of slow views. So we download that data of the slow views on our workbook. We run our checks using the Metadata API, workbook XML. We then take our results found data object, we send it back to the Tableau server. So we have a rules engine, scoring engine within Tableau server that gives us the final score of what we found. And finally, we combine all of that information into the results email that we see. So let's do a quick demo. Okay. Let's say I'm a new publisher at your organization, and I've taken all the e-learning. I've taken all the e-learning, done all my training, and I think I'm ready to go. And I actually go about and I create this dashboard. I publish this dashboard, and it turns out the dashboard's actually performing kind of slow on the Tableau server, and I'm not really sure why. I try running the performance recording, but it's not telling me much. As we know, those can be hard to read sometimes, especially for new users. I'm really struggling to figure out why my dashboard's performing slow until I get the Design Auditor email. This email lets me know what's going on with my dashboard. So I first see that why my views were pulled, and I see here are my results. I see where the project can be found, where the dashboard can be found, screenshot of the dashboard, how my render time of this dashboard compares to the server average, and finally the score. So this dashboard scored an 81 out of 100, and here are the criteria that made up that score. We have our number of worksheets in the view, 4% of hidden fields, looks like it needs improvement. Number of LOD calculations, global filters, context filters, relevant value filters. We check, is it live or extract? Does it use custom SQL? Row level security, workbook XML size, number of worksheets in the workbook, number of dashboards in the workbook. So that's my result. If I wanted to say for number of dashboards in the workbook looks like I need improvement, I could click this link, go to an internal wiki page to learn more about why it's important to limit the number of dashboards in a workbook. And then I got a couple more results based on the latest run. So that is the result of Design Auditor. Let's take a look at the configuration dashboards and the results data source. So here are the Design Auditor results. This shows us which days our script has run, our application has run, and what it found when we're auditing these dashboards and views. What's really nice is we can see a trend of what views are performing excellent, consider revising, needs improvement. The sites, how each site's doing, how each project's doing, how each user's doing, and the different criteria, how the group's doing it all together. So it looks like percent of hidden fields, we could use some work. We seem to be struggling on hiding unused fields. And then we can also see trends for users. So if I click my name, I can actually go to the scoring details dashboard. And I can see which days my scripts ran, which month, how my views performed over time. We can actually start to see a trend on, we're running this tool, are users implementing what they find? Are they building better views? What's really nice is all this data is stored using the Hyper API. It's a published data source, so we can join with the additional data as needed. And then the last thing I want to show is how do we configure this? So we have this first view. We have this first view with these parameters on the right. So we can determine the render duration threshold, what is the median render time need to be before we flag it? How many views do we want to send in each email? So that's what these two configurations do. And finally, we have our scoring configurations. This allows us to customize the results we get per customer. So we have our points per result, and what we do is we do a sum weighted average. So this allows us to weight the different criteria we're checking against and set the limits. So say maybe your organization uses a lot of live custom SQL and you want to try to cut back on that. We can actually set this weight higher so that it affects the Design Auditor result higher, gives it a higher impact on the score. So it's really nice is all of this is totally customizable client to client. So I know we talked about a lot of stuff today, but I just want to do a quick recap. We discussed when to use the Tableau Server REST API, how to use them, including the Tableau Server REST API, Hyper API, JavaScript API, Metadata API. We discussed how they work, when to use them, how to use them, and we gave you some really good examples of using them. But there's many more APIs out there. We're really excited about the new TSM API, which allow us to turn the TSM command line and actually use it as a REST API, introduce it to Python scripts. There's our extensions API, creating Tableau dashboard extensions, and our webhooks API. We didn't have enough time to discuss those today, but that's all part of our Tableau developer program. If anything we talked about sparked your interest, or you could see yourself working with these tools, I recommend signing up for this program. It's free. And what it does is it's a one-stop shop for all your data dev information, resources, and the data dev community. So that's all we had for our presentation. We'll now open it up for Q&A. And I just want to say at the end of this presentation, there's links. So any good references, anything we talked about, our scripts can be found here, can all be found on the links page of this presentation.
Thanks, Andrew. Thank you very much. That was great. So I've tried to answer as many questions as I can in the Q&A, but we have about 12 minutes left on the session. So I guess we'll answer some live. Maybe start at the top one, which was the most upvoted. The question is from Graham, where he says he's asking, really struggled with assigning AD group permissions to a new project, first with TCS and then with Python REST signing in with token. Can you point to some sample, please? So I guess the question is around
project permissions
and tokens.
Yeah. So Graham, so I would kind of there, you can look at the example I gave using TCS, Tableau Server Client. So that code's actually going to be shared. And then with Python signing in that more complex example I showed you, how we did kill the pinning jobs, I actually have the code in there to get your authentication token and how to use that token on your next REST calls. So I look both those spots, and then in this links page I shared, there is a Tableau Server Client reference library, and in there's actually examples on how to use Tableau Server Client. And if you check at the issues for this GitHub repository, you actually see they're working on their permissioning examples documentation because it's relatively new. So it'll be out there on that documentation soon.
Awesome. Thank you, Andrew. Let's see. Question from Shankar. What are the prerequisites for using the REST API? Is there any prerequisites that we need to make sure we have?
No. So the APIs are enabled by default on your server. Mainly, you need it's pretty much like using any scripting language. All the documentation's there. You just need a Python, a tool to be able to call the REST API, and then the resources to know how to string those together. But again, there's really great programs on the Tableau Developer Program to teach you how to do it. It's a really low barrier to entry to use them.
Cool. Thank you. I see a lot of questions around metadata APIs and custom SQL. So do you have any clarifications that we can provide around custom SQL in general in the metadata API?
Yeah, so if you go to the metadata API reference, oh no, can you see that, Emiliano?
Yes.
Okay, cool. There's these sample scripts. Oh yeah, so if you go here, the sample scripts can be downloaded from GitHub. There's actually a sample on our GitHub for custom SQL. So I would say custom SQL examples, metadata API with Python and TSC. I would say take a look at those two when you're curious about using custom SQL tracking. That's a great starting point.
Fantastic. Let's see here. Another great question from Josh asking around the metadata API. Is it available without the server add-on? So yeah, I'm guessing he's referring to the
REST endpoint of it.
Yeah, correct.
Yeah, so it actually is. So you can run a TSM command to turn Tableau catalog on in the background, and then you can use the metadata API just through the REST endpoint. You won't get any of the features, UI features you'll see on the server, but that REST endpoint will be available to send metadata API queries to and get results. I would be before you go and turn it on, there is some considerations. Tableau catalog, the initial indexing takes some load on the server. So you just want to make sure you're well aware of the resources, if maybe you need to add additional resources before you go and turn it on.
Awesome, thank you. let's see here. I guess there was a question from Fabian asking, is it possible to update the metadata from a published data source? So I'm guessing, is it kind of extrapolating here, but is it possible to go and update maybe connection details or certain, what can we update on a published data source, let's say?
Not much. So what you can update the connection details. So like the server it's pointed to, your database, your username, password. That's really it. The rest of it's all handled by the XML of the data source, and we can update those with directly with the REST API.
But we can add details around around metadata of published data sources, maybe adding descriptions to columns and things like that. That can be done through the Metadata API, right?
Yes. Well, we can add descriptions to the catalog columns, not the actual data source columns themselves. Perfect. So there's a little that can be done, but most of it's connection details is what the REST API.
Okay, let's see here. So there's some questions also on how can we add users and groups to the server programmatically? Yeah, so there's REST API, common answer. So actually, so on here, we have our REST API reference, right? And so how this reference works is you can go, there's all these different methods, and there's this users and group method right here. So we can actually look at how do we add a user to the group, how do we add a user to the site, update group, update user, remove user from group, remove user from site. All the information is here in the reference. This is directly calling it. And then Tableau Server Client also has its own references for how to go about doing that. But it's it's hard to say exactly how to go about doing it. It's going to be different for each organization, but that's where you'd want to get started, is those two references spots. Thanks, Andrew. So a question around the Hyper API. Jeffrey asks if we can read data from a .hyper file through the API.
Yeah. So you can read a .hyper file. There is one restriction. You have to have that .hyper file locally to where you're running the script. So that is the one thing right now. So you'll need to download, if it's a published data source, you'll need to download it to read it as the current state. But we can read Hyper files with the Hyper API.
Awesome. There's one more from Eldar regarding the Hyper API around optimizing it with inserting with a bulk option as opposed to row by row.
Yeah, so there is a bulk option. That's if you use CSV files. You can bulk update, like if you have a CSV file, you can bulk update that and import it into your Tableau Hyper API. But since I was using a Pandas data frame, we can't bulk upload that. So it's just based on how you have your data, is if those options are available to you. But yes, there is bulk uploading CSV files into Hyper APIs.
Awesome. And just to add to that, we, if you're looking for more sort of ETL, there is also prep that can output to Hyper files if you don't want to use the Hyper API.
Yeah, so here is an example of a create Hyper from CSV file, where you use the copy command to pretty much populate it.
Great. There's a question from Vivek. He's asking, which editor do you prefer to use to write this code?
So I started off using Visual Studio Code, which is great. I use that or PyCharm. I used a mixture of the two, depending on what task I'm doing. So most of the when I'm writing anything backend really heavy in Python, I'll use PyCharm. Then if I'm creating HTML, JavaScript, do anything like that, I'll use Visual Studio Code.
Awesome. There are a few questions on the code, if we will share it, and just the materials. And yes, we will share the code. We will post in the forum and link back to the admin user group forum, where we will definitely add the slides, the recording, and any sort of code with the Python scripts that you see here will be shared.
Yep.
So
yep, exactly.
maybe we can have one last question. Andrew, I'm not sure if you can see the questions. But maybe
yeah, I haven't been. I'm looking at them now.
Fantastic.
Let's look. I like this question about, can we read permissions? So that's actually, I hear that all the time. With the Tableau Server REST API, if you're a server or site admin, you do have the ability to read permissions on the server. So that's one of those functions that only server site admins can do, is read permissions with the REST API. And then the killing pending JavaScript, it is actually in this Ignite folder that we'll be sharing. So if you click kill pending jobs, you'll get the full code and the services. You can see how we're directly calling the TS API.
One last one, I guess. Let's see if we know the answers. Is it possible to update a connection details, like updating with new password?
Yep.
Fantastic.
So
cool.
how if you have any questions about the REST API, this is how I always go and find it. So I go to the API reference, all methods. It would be, we'll just say we're doing it for data source. We want to update data source connection. So how it works is we send this URL, then we have this request body. So we can actually put the new password in the request body, and then it will be updated.
Thanks, Andrew. And there's one last one from Michael Lane, where Michael is asking about onboarding and kind of facilitating that, where they use Windows AD on one server and they plan to use SAML on another. And he's asking if they can use the API to automate the syncing of the server 8 with AD for when users are added and removed from the system.
Yeah, that definitely sounds possible. I would say Tableau Professional Services has helped many clients accomplish things like this before. So I'd recommend reaching out to your AE, set up a call with Professional Services. We can help you consult on how to do it, or even help you build the solution.
Yeah, the methods are there. So you'd have to you'd have to use Michael. You have to use some of the methods that we showed around adding users, making sure that the license correctly. All those things are available through the REST API. But if you're looking for a kind of a complete solution, just like Andrew said, you can reach out to our team. All right. Well, thank you very much, everyone. We look forward to sharing all our materials. Thanks for everyone for attending and for your excellent questions. I hope you found the session useful, and we wish you a good rest of the day or night or wherever you guys are. Thank you very much.
Thanks, everyone, for joining.